Good afternoon, everyone. Evening. If anyone is super thirsty and you want a LaCroix, whatever they're called, there's like 3 in that box over there left over from Friends of Science and Medicine seminar. There are 2 more this semester, one in March and one in April. If you go to that link I sent out, there will be the dates there, so you can put it on your calendar. The seminars are really all about that big picture. So we had, I think, 5, 6 people from class that went. Does anyone want to share whether they thought it was valuable or insights gained from it? Kat? Dr. White?
Dr. White, she told us about that, she told us that she basically ended up doing something that she didn't think she would want to do, because she started with computer science and then she ended up doing something completely different. So it wasn't right for her.
I do think it was really especially cool with these 2 because they both, if you looked at them after the first couple of years of college, would think that there's no way that they could have a career that they did, and they were able to make it work with mentors and appropriate efforts and kind of connecting things together. So please do consider going for the next couple. We do provide pizza this time. I'll see if I can get better food in the future. But it is for y'all that I developed this seminar because a lot of people in here are thinking about a career that involves helping people, that involves medicine, and so these kind of connect you to parallel or people in the field. Last spring we had a lot of students actually shadow people that came to the seminar series, so keep that open. I don't have the dates off the top of my head, but maybe if someone wanted to pull it up on the computer, then I could announce those dates so you have them on the calendar. Let's go ahead and dive right in. We're going to kind of zoom out in a little bit and talk about the class, but for now, we have the first question of the day up on the board, talking about the Van Hoff factor. So with an experimental value of 2.8, which of these compounds could be possible if you found this Van Hoff factor from either freezing point or boiling point or something like that? So go ahead and pick either just one, more than one, none of them. Type in the number and hit send. Once you've made your choice,
3 and 4.
talk over your logic with your table mates.
No, 4. Yeah. 1. I wrote them down. Good. 1 and 3. So 3. Just 3.
All right, a couple more seconds. You need to submit your answer. 2 numbers. It's not good. You have Wi-Fi on? Are you on the UALR Wi-Fi, not the guest network? If you're not on the UALR, refresh. Okay, 24 responses. All right, let's take a look at what responses we have, and then let's see if we need to discuss them. We have 9 people that said 3 only, 3 and 4, 35, 3 and 5, 1 and 3. All right, so we have a mix. We're kind of all over the place. How do we answer this question? Can I get a volunteer? Amber? What do you mean break them up? Before you even do that, what do you need to do before that? Oh, tell me the steps you did to break them up. I think it's implied in there.
So you have the sodium
So we need to write out the formula first. And then once we have the formula, we need to then say what happens when we separate. So if you don't know your polyatomic ions, this question is probably Martian language to you, or not very comfortable. So next week I will have a question that's a lot like this on the exam. So make sure that you get your flashcards, go through, memorize your polyatomic ions. They are the language of chemistry, and we're not going to stop for you to look them up. They're one of the few things you do have to memorize in this class. So what is the formula for sodium chloride? All right, we got NaCl. That one's not too bad. What about sodium sulfide? This table here, sodium sulfide. What's the formula? Any one of the five of you. Sodium sulfide. What's the formula? Do we agree? Na2S?
Yes.
Okay, so sulfide is S2 minus, so Na2S is the right formula for that. All right, this table here, calcium phosphate.
Would it be Ca3 and then like parentheses PO4 and then like close parentheses 2?
How do we feel about that? Okay, so calcium has a 2 plus charge, phosphate has a 3 plus charge, 3 minus charge. So that gives us a neutral salt. So then we do what Amber was talking about. She says, if we put it in water, how many individual ions are they going to break into? Basically, what's their Van Hoff factor? What's their theoretical Van Hoff factor? So we're going to do theoretical Van Hoff factor. So what is it for acetone? How many particles are made for every acetone that goes into water?
Just the one.
Just the one. What about sodium chloride? 1 sodium ion, 1 chloride ion. And the reason the acetone only has 1 is because there's no ionic bonds. So once acetone goes into water, it doesn't dissociate into individual ions, but it will dissolve. Sodium chloride is 1 sodium and 1 chloride ion. What about sodium sulfide? Oscar, Kevin? 3. 2 sodium ions, 1 sulfide ion for every sodium sulfide that goes into water. Okay? And then, Michael, what about calcium phosphate? 5 ions. So Van Hoff factor of 5. Okay, so these are all the theoretical Van Hoff factors. So we saw a mix of responses. Which one of these could potentially give an experimental Van Hoff factor of 2.8?
Anything above 2.
Anything above 2.8. So which ones are that? So this could either be sodium sulfide or it could be calcium phosphate. It depends on if you put calcium phosphate in water. Does it actually separate into 5? Or do they stay together a little bit and only some of them separate into those individual components? So theoretical Van Hoff factor gives you an idea of the maximum possible particles you can have in water, but it's not the actual number. You actually have to go measure that by putting it into water and figuring out how many individual particles are made. And that's one of the things that boiling point and freezing point are used to do, is to tell you, well, how soluble is it really? Does it actually dissolve the way that you think it will, or does it dissolve less? Is it more likely that those ions are going to stick together than separate out? Any questions how we'd answer that? Theory behind it? All right. So, why was that the wrong answer? Did you guys follow your solubility tables and look at that? What happens when calcium phosphate goes in water? So calcium and phosphate, where those two intersect on a solubility table, it's a dark square. So what does that mean? It means it is insoluble.
So what is the theoretical Van Hoff factor for calcium phosphate? It's about 0. You don't get any particles because they don't dissolve. So what I'm trying to point out here is that we can say that things are supposed to dissolve, that we might have expectations of what's going to happen, but we need to take into consideration the bigger picture. So when you have calcium ions with phosphate ions, they have such a strong attraction between them that when you put it in water, water is unable to wedge itself in between and push those apart and generate dissolved ions or disassociated ions in water. You have a question on that, Jessica? Stretch it out. So what pieces of information do you need in order to answer a question like this? You need a solubility table. I will provide this on the exam. You are not expected to memorize this. What else do you need? What's that, Kevin? Well, the solubility rules are summarized in this table. So the nice thing is, you don't need them. My philosophy on life is if there's something that you can look up that you're going to use infrequently, you need to know how to use it once you look it up, but you don't necessarily have to memorize all the things. So electronegativity table, that's something I'll provide you in the exam because I want you to know the trends, and if something is a metal and a non-metal, that they're going to form an ionic bond because they have a very different electronegativity value. But you don't need to know the exact differences. You can look that up for things that are close together. What else do you need in addition to this table to answer a question like this?
Memorize your polyatomic ions.
You need to know your polyatomic ions. If you don't know those, I'm not going to provide them to you in the exam, and you are not allowed to have them on your note card. So if you have anything on your note card that says name and the ion itself, or anything that tells you the name of the ions, then I unfortunately have to take your note card away from you. So please don't do that. That would jeopardize the rest of the study tools you put on that note card for yourself. All right. So if we're talking about what we're trying to do in class today, we're going to spend some more time on calculations. We're going to be looking again at freezing and boiling point. But then we're also going to spend a little bit of time thinking about converting between different forms of concentration units. The ones that you're going to need to be most comfortable with are the first three. Molarity, which is big M. Molality, little m, and mass percent. Sometimes you see it written like this. You also have percent volume, like wine is 14% per volume, ethanol, that type of thing, but we're not going to spend as much time on that. I also do want us to be able to do what you practice in your primer, which is osmotic pressure, and thinking about kind of what that means visually. And then we're going to use all these. I think the most useful thing about colligative properties is you can use colligative properties to identify the identity of an unknown through any of these three properties. You can find its molar mass, you can find its Van Hoff factor, one or the other. You can't necessarily do both at the same time. So it gives us a lot of tools that we can use to find identity. A couple notes I wanted to make. In the announcement I sent out via email and announcement last night, I sent out 2 surveys. I collect data at the beginning and end of my class in order to see if I can change things in my class to improve student outcomes. Those 2 are extremely important to me. That means that I need you to go through and answer them and actually spend the time answering the questions. It shouldn't take more than 10 minutes each. I think it's actually closer to 5 minutes each, from what I've been told. And if you complete both of those, then you get 100% on your post-quiz for week 3, because we didn't have a post-quiz. So that's where I will give you credit for completing that. There will be something similar at the end of the semester, and I will be doing a comparison of the 2 and looking at how students are doing beginning and end of the semester. I have not been having a lot of students come to office hours. I only had half of the class answer my original poll on office hours. So I was wondering if I could have a show of hands if we should re-poll for office hours. Because it can be some of the most valuable time where you really get to sit down and work through problems. And it's very much group-oriented. It's in a space that's not too different from this. There's one table instead of all these little ones, but we all just sit around it, a big whiteboard, kind of work through problems together. So my office hours right now are Tuesdays 3 to 4:30, Fridays 12:30 to 2. That's based off of the survey results that I had. Should I re-poll and try to find different times throughout the week? Raise your hand if you would like me to re-poll to see if we can find different times throughout the week. Okay, I will send that out either tonight or tomorrow. So please make sure you respond if you will use office hours. And I would encourage everyone to come use office hours. It is not for students that are only struggling, not for students that are doing really well. It's for everyone. And we can all sit down together and learn together. So it's a really nice informal time to bring some of the material and kind of work through it. What about workshop? I should ask about that as well. We had 4 students come to workshop yesterday on Tuesday, which is 6 to 7 p.m. We typically have about 10 people come before this class. We have Friends of Science and Medicine today. Should we re-poll to find different times throughout the week where we have people available to support you with a supplemental workshop? Raise your hand if you'd like, if those 2 times don't work for you and you'd like me to re-poll for those. Okay. We have 2, so I think that's probably not enough to tip the scales. However, you can come to office hours and do this as well. So if you come to office hours, I can help you work through it and answer questions. So make sure you put in your votes for office hour change times, and we will find those. Hopefully that'll work for the people that want to utilize that resource. Even if you can't make those times, send me an email. You can stop by. We can work on it together. My schedule is relatively flexible, so hopefully we can make that work. I wanted to bring up a question about workload. How do you all feel about the amount of work that you're requested to do outside of class? And let me put a bracket around that and say that my philosophy is, if you come to class not having tried to work through the problems we're going to be doing in class, then typically very little progress is made during class. So I need to have some level of engagement before. However, I don't want you feeling like you're on your own and that you're spending hours and hours and hours before each class just trying to teach yourself, and that you're not seeing the connection between that and in class being what you need to prepare you for what is going to be on the exams and assessing kind of what I want you to do big picture. So would anyone like to volunteer their thoughts on workload, whether it seems excessive, and if so, which parts?
I thought the homework this past weekend, the end of it, was a lot of what we hadn't done, so I was sitting there having to do it, like, all the tries on each part, and there were, like, a bunch of different sections with 4 questions each, so, I mean, it took me a while to get through some of the sections, because I didn't know how to do it.
And then the being about 3 simple questions.
Yeah, it was pretty long, so,
Yeah.
and I was doing them, like, multiple times to try and figure out, like, how to do it.
So if, what would be ways to work through that if there was questions that required a lot of attempts? What are ways you think I might suggest? So Blackboard discussions, there still hasn't been a single post there about, hey, I'm trying to do this type of problem, like, what am I missing? Or that's maybe if we have somewhat of a framework. So maybe your point is we didn't even have a framework to work on it yet, which is fair. So if we do have a little bit of a framework, you can post something, or you find a great resource. Like, this little 5-minute video really helps with question set number 6 or 7. Post it there. I would say at the beginning of the semester we have been a little misaligned because I've been trying to keep up with previous semesters, but we did add a whole extra day of the concept mapping to try for me to understand where you're coming from, because I have had very few of these students, you all in class before. I think that we're pretty much on point now. So exam 1 should be a reset point, and hopefully going forward you will find the homeworks will be things that you have seen before for all of them. And this week, homework 4 should be. That may mean that the primers are still a little bit of, or still going to be new information, but hopefully it won't feel as much of an overload. So you are the individuals in the trenches who are going through it. I want you to be the voice that tells me if you feel like things are misaligned or do not work for what's going on. I don't know exactly where you are in the process of going through this, so please don't hesitate to reach out to me and be like, hey, Dr. Bailey, I think that there might be like a little bit more on this than you expected, it's taking longer for a lot of students. I talked to other students and it feels like there's too much. I very much am receptive to that kind of feedback, so please don't hesitate to give me that feedback, okay? Yeah.
Not the last primer, but the primer before, I think it was. I struggled with that a lot, and then there were only 3 tries, and I messed up the first one because I tried to do it, and then had a hard time with the other 2.
You can study while you're in it.
Yeah.
Yes.
But then the next one had more tries, and I was able to get it. I just struggle when I'm trying to figure it out.
Yeah, so the primers are set up specifically for you to try it before you do any studying. I want you to. First one is, what are we going to be looking at? And if it's the adaptive study ones, the ones with the couple lines, that are across the whole page, you take the quiz, then that's specifically set up to guide you to the part of the reading that might help. Or the ones are 2 different types, the ones with regular questions, the same idea. I want you to go through, see what you know, what you don't know, spend your time studying that. So hopefully the 3 attempts are good for that. If you mess one of them up, then it kind of sets you back a little bit.
Are they for completion or grade?
Once you have to finish them correctly, but you get 3 attempts to do it. So all of the components are, if you get 3 out of 4 right, you get 75%. On the post quiz, that is, you only have the 1 attempt. On the other assignments, you have either 3 or unlimited attempts, or 10 attempts, I can't remember what it is.
Yeah.
Yep, so it is, you have to get it right. You can't just be like, oh, I tried it, I'm done. Because that would not motivate people very well to keep going if they didn't get it right the first time. Is that fair? Okay. If you are concerned about your homework grade right now, we're only about 20% into the class, maybe a little bit less than that. So we still have tons of time for your homework grade to be stellar. And we do have the workshop, so if you are able to complete the workshop activities and turn them in on Wednesday to me. I hand them out Monday. If you turn them in Wednesday, or if you go to the workshops, either one, then that definitely adds to your grade and helps boost that part of your grade. All right. If you have any other questions or comments, and you don't feel comfortable doing that in front of class, stay after class, send me an email, come by my office. We can chat. And one other component about the struggles that you have. Hopefully you will find that by engaging with the material multiple times a week, you will be more set up for the exams and won't have to do as much kind of cramming and intensive studying before the exams. All right, let's take what we just did towards the beginning of class and let's apply it to another problem. Do you need to convert it here? Is that important for solving the problem? Why? So discuss with Oscar and I'm gonna say, yeah. That's my ballpark, but not. Alright, so 30 more seconds. If you're doing the math for every single one of these, you're missing the point. All right, check at your tables. Are we in agreement here? I'm going to say that we might not be in agreement. Can we have some debate, whole class debate? Can I have some people volunteer their thoughts and maybe confusions? You want want to talk to your tables first for a few seconds? All right, discuss your tables first. Which one you chose and why? What are the concepts in play? Can you go back to these questions? Oh, I didn't send the... Is there any information you'd like in order to answer this question? Should have put that in. Maybe I can advise, do you all want to just take a picture of this on your cell phones? I will provide it on the exam, I promise. But for other questions like this, it might be worth having. Looks kind of comical. What's that? You got it? You don't got it.
Seems like A and C and D would all associate into three things.
What just happened? What's going on? Go back to that. All right, has everyone submitted their vote? Interesting. All right, Jesse, you mind sharing the discussion at your table?
Well, it seems like magnesium chloride, sodium sulfide, and magnesium nitrate would all break down into three different things.
So the theoretical Van Hoff for those are 3. What is it for magnesium sulfate?
2.
Sodium sulfide, you said was 3, and about 0. This is not really soluble, right? So how do we answer this question? Can we?
Would you put a 0 in here on the equation?
You can't even calculate the change in boiling point. It's basically like if you add a lead bar to water, it's not going to change the boiling point because nothing dissolves.
So it wouldn't affect, so it wouldn't have like the same effect, like throwing something in there that's like, what was something else we used, like the acetone?
Yeah, so the acetone will dissolve, and that does disperse evenly throughout the solution. So that has a Van Hoff factor of 1.
Okay.
One particle results in one particle.
I get what you're saying.
But the magnesium phosphate, one particle results in 0 in the water.
Yeah.
So that's why we kind of say 0.
It's not even getting
Okay. So is there a clear answer here? All 3 of these will have a similar impact on the boiling point. Is there one we could say will be the clearest minimal change? So magnesium sulfate is only going to have a little bit of a change compared to the change seen by the other ones. Stacy, you have a question?
Oh, I was gonna say something.
Okay. No worries. So on this question, I would be, I should have had a 4th answer, a 6th answer. Many. Or this would be one of the ones where you do like a multiple select answer. But it creates discussion, so it's good, right? All right, let's do the next one. The next one's a better question. If you convince yourself it was one of the previous ones, then you were wrong. That's the right answer.
What did you say the M mole was? The M mole? Oh, no, you're asking what the M mole. It's 1,000 millimoles.
12,000 moles of, is that what that's saying?
Now you would divide by.
So it's just 12 moles. Or am I just thinking about that?
What, is that true?
I don't know. A millimole? I've never even heard of that before.
Yeah.
So 1 millimole is 0.001 moles.
Alright, let's do another 20 seconds.
Well,
Yes.
Alright, a couple more seconds. Submit your response. We're split 50-50. Alright, who wants to argue for A and who wants to argue for B? Can I have hands raised for each of them? I'll have one person argue for A, one argue for B, and then we'll hear about why, and then the class will decide. Which one do you want to argue for?
B.
Okay?
19 times 2 is 38,
Why did you do times 2?
because it's going to associate into two things. Magnesium and sulfate. And then A, 12 times 3 is only 36.
Okay, so which one of those is going to have a bigger impact on boiling point of water? Is it the one with more or less? Is this like a dumb question? Okay. Sometimes. So remember, we think about those heating curves. Right, we have solid, liquid, gas, and we have those two phase changes. Remember that when you add a solute, the two phase changes, the boiling point goes up, the freezing point goes down. So we end up with a bigger difference between the two. So in this one, we're going to have, this is the largest change in boiling point because it has the most particles in solution. Could you calculate the actual change in boiling point? If we had delta TB equals I times KB for water times molality. Could we calculate that if we wanted to? If we had the KB, which you'll be given on the exam. Okay. Could you rank these? Which has the highest to which has the lowest change in boiling point? Samantha?
Wait, I have questions. Said it's A because there's no particles, but,
Did I do that wrong? I totally did that wrong.
okay.
Okay, I was ready.
Sometimes you just gotta throw stuff at me, you know, when you're talking and you just don't know what you're saying. Don't you like gibberish? Isn't gibberish awesome? Yeah. It's one of the things that you learn is when you're trying to think 2 steps ahead, it usually doesn't work for the thing you're doing right now. Thank you for pointing that out. I appreciate that. Okay, so the one with more particles is going to have a bigger change. So that is the highest change in boiling point. Could we rank the others? Go ahead and do that really quickly. Rank the others as far as next highest change, next highest, next highest. Couple more seconds. Okay, so the first highest boiling point is B. Magnesium sulfate, 19 millimoles. What's the second highest? A? Because it has 36 millimoles of particles. What is the third highest boiling point? Why is it C?
It has 33.
Okay, and then our next lowest? 9 times 3 is 27. And then our lowest boiling point? Why? Because the change in boiling point is 0. So it would be the normal boiling point of water. All right. That is something you will see on your homework and your post-quiz for this coming week. So make sure that you're able to go through that process. From name to formula to relative number of ions in solution in order to find the change in boiling point. Okay. So now let's go ahead and I guess I'll hit the talking about a leave, and this is one of the applications of how you can use freezing point. So go ahead and check out, read through this answer, see which of these you can support with calculations. So if you need additional information that I've given you in the past, go ahead and pull that out. What information might you need that you already have? Use some constants we used last class. You just watch the video and then you follow along.
I haven't had a chance to do that yet.
Always if you can, try to do it before the next class so that you feel it. So what values? Have you done a primer?
Yes, what's
For water. So now, try to figure out how to use that tangent.
equation, if you calculate I is 1.9. So it can't be 1. So you would assume.
Samantha, you have an idea where to start? Can you ask one of these two? Alright, how are y'all going about this?
I found the change in temperature.
You found the change in temperature?
Yeah.
Based on what?
I think it went from 0 to negative 0.363. And I was going to use that to find the molality.
Okay. Did y'all go about it a different way or same way? Okay, so you know the molality, right? Because you know the moles of solute and you know the kilograms of solvent. So then if you know the molality, what can you find? What you might find might tell you something different, which is interesting as well. So, go ahead. If, kind of, you have to make an assumption though. If you're finding the freezing point, what assumption are you making? What's the equation? What are the components of the equation? So that's not the freezing point. 1.86 is the freezing point constant for water. So think about all the different components that are in that equation.
Is that a problem? So see, if you multiply it by 2, you get...
The change in the temperature is the negative, or is the final.
So does this hurt your brain a little bit? Try to like use the equations. See some people saying yes, some people saying no. What the general approach is in any problem-solving process, not even, I was going to say just in any chemistry, but not even chemistry, in anything, just think about what you know and what you're trying to find. So we know that this is a freezing point depression, and we're trying to find out information about it. What specific information are we trying to find out about this compound? What's that?
Van Hoff.
The Van Hoff factor. So if it's ionic, the Van Hoff factor is always greater than 1 if it's soluble. If it's not ionic, but it's soluble, the Van Hoff factor is 1. So if we find the Van Hoff factor, we've solved this problem. So where is the Van Hoff factor? How do we find that?
You have to use your constant. You have to learn the molality first.
Even before that, I'm going to say we just need to know that the relationship is that the change in freezing point is equal to the Van Hoff factor times Kf times the molality. Okay, so once we know that relationship, which some people call an equation, we know that if we have everything, if we have all the variables except for 1, we can find that unknown. Because we have one equation, one unknown. Do we know the change in freezing point? It decreased 0.36 degrees, 0.363 degrees from 0. Do we know Kf? It's a constant. Do we know the molality, or can we calculate that with the information we have? So this is really just about zooming out, thinking about what we know, what we're trying to find, and making sure that we can follow the steps together. The next one we do like this is going to be much harder, but we're thinking along the same lines of what do we know, let's at least find out all the things that we do, and then figure out what's left. So in this case, we have negative 0. Or actually, I'm just going to say our change is 0.363 degrees Celsius, because that's a change, but we know freezing point always goes down, equals our Van Hoff factor times 1.86 degrees Celsius per mole. And what's our molality for this?
0.100.
Because we would divide the number of moles by the kilograms of solvent. So if we rearrange the equation and solve for I, what do we find for I, Taylor?
1.95.
What does that tell us? It says that it is ionic, and what else does it tell us? What more does it tell us?
have theoretical now.
So we both have the experimental. We actually don't know the theoretical yet. We only know the experimental Van Hoff factor is 1.95. What does that tell us? Does that mean that our theoretical Van Hoff factor is 2? What does it tell us, Sydney? Okay, does anyone want to help elaborate on that? Great. Tells us it's anything greater than 1.95, which is greater than 1. So it could be 2 ions every time you dissolve it. It could be 3, it could be 4, it could be 5. And those ones that are higher just don't fully separate. So it turns out that it leads, did anyone look it up on their phone, what the structure or formula is? It's a sodium naproxen is the compound, so it has 1 sodium ion, and then naproxen is an anion, so it's actually a theoretical Van Hoff factor of 2. Alright, let's take this and try to use it another way. So that one, we did agree that that was ionic. You want to make sure that you keep your children's Tylenol as long as you can, because the kid that you have in your house might need it very quickly. But the colder you keep it, the longer it lasts. So if we put it into our freezer at minus 18 degrees Celsius, is it going to freeze? Try to figure out how you can use the knowledge that you have in order to answer that question. And you might need to Google something in order to answer this. Wouldn't that be a great test? You Google whatever you want.
You can use your smartphone. Well, I mean, in real life, you can use your smartphone.
I need to figure out how to process that. Just make the test range.
There was this guy on Joe Rogan that talked about why can't I have part of the test?
Well, you gotta fill out this part, because that part's the same part. Part of the argument, temper.
Maybe I could enable this thing a little better.
Alright, if your group is stuck, make sure to flag one of the 4 of us over. You have a lot of help here today. Come on. Great. So because we're talking about change the rate of flow, it makes sense to use the relationships that compares solute change.
I almost don't wanna use that.
So, I think the only thing I'm missing is like the KF of acetaminophen. But I mean, I don't know how to find that. So I guess that's not what I'm supposed to be looking for.
So, what do you think that both of the refrigerator kitchen, which is shaped to minus a delta source of you think that A?
I haven't said anything. I was asking what the KF acetaminophen was.
I haven't
So it's like converting. Yeah, it's grams, so it's just like 1.16 grams.
so that means we need to calculate. So did you calculate it?
Calculate the
The
what?
concept is that delta T value should be greater than 1800 and only it will not freeze because for you can discuss with them.
So you'll multiply 18.
We need to write into this one.
Multiply 18 by. So it's Van Hoff factor is 1. It's not gonna follow. It's not gonna break apart.
So just
So you
one.
can go about this color ways.
So,
You can either find
so I think that one. Have you got that key value from Anchor?
or, yeah, and so you could say where is the frequency?
Definitely it will not.
Right, you go 45, depends on what unknown you want.
No.
Is that not useful at all? So if you solve for delta T, you would have to know your mortality,
That is
KF,
given to
and
us
your
minus
ion.
something.
You know those things.
We need to find out that the delta T,
What's it dissolve?
if that delta T is greater than
Make your body
18 degrees Celsius,
always
then it won't freeze. Otherwise,
so you know your KF.
that's the concept.
Can you find
So
what
you need to
water and then you go.
this the appears from the Google.
And then if you load it into the structure, you can determine
From this setting.
advanced
And multiply it, if it is greater than minus 18, it won't feel back.
So 500 sure.
What is the value of Q?
In a solution, you almost assume that solvent weighs as a solution because the solute is such a small part of that. So if you can figure out how heavy that is. Figure out? Yeah.
So I'm gonna briefly check in and make sure we're all on the same page and kind of doing similar things. What framework do we really need? What are the things we need to explicitly write out in order to start solving this problem? What are the most important things to write down? So we need to make sure we think about our values, and we need to make sure we think about, we're talking about the change in freezing point. All right, is everyone thinking about this as a change in freezing point problem? Which ones of these do we know or can we find, and which ones of them are we trying to find? So you're trying to find the molality in which way? Like you're trying, that's your unknown, or is that one of your knowns you're trying to calculate? So we can, in theory, calculate. We can calculate molality. But in order to do that, once again, we need to write out exactly what that is. So the way that I would go about this is molality is moles of solute per kilograms of solvent. Here's two things we have to keep in mind. If we're ever taking a drug and it's a solution, it's always going to be in water. You would almost never put something else into your body. There are a few exceptions where we dissolve things in things other than water, and it usually is very toxic, so we have to think about cost-benefit analysis of that. Okay? So that's number one. So our solvent is water. Number two is that if we have a solution, and it's a solute dissolved in a solution, in a problem like this, we're always going to make the assumption that the mass of the solvent is about the same as the mass of the solution. So that means that if we're thinking about we have 5 milliliters of solution, if we know how much that weighed, we'd say, well, that's about the mass of our solvent. Without those two assumptions, we really can't answer this problem. So do we know how to find the number of moles of our solute here? So we have 160 milligrams of Tylenol or acetaminophen. How do we convert to the number of moles, Kat? What is it for Tylenol?
151.163 grams.
Okay? So that's what goes on top of molality. What about on the bottom? How do we find the kilograms of solvent? Is that where people are getting stuck? How do we convert to grams? What do we convert to grams? Oh, you're saying the Tylenol? Oh, sorry. I typically do it in my head. We can't. Either way, whatever works for you. If you prefer to convert milligrams to grams, grams to moles, totally cool. Or you could do that, because if you've converted enough between milligrams and grams, you might just be able to see it and move it in your head. So then how do we find the numbers of kilograms of solvent?
We have to use that first assumption, it's water, in which one,
we need a conversion factor to go between how much space it takes up and how heavy it is. What do we call that conversion factor? Density. So with water, that's most frequently 1 mil weighs 1 gram.
When is it not?
It's not when it is different from 4 degrees Celsius, because water expands or contracts slightly as a liquid. And so if you're at different temperatures and you're doing very precise work, you actually need to use a much more precise measurement of density. But for this type of work, we can say 1 mil per gram. So then we have 5 grams, but let's go ahead and say we have 1,000 grams in 1 kilogram, and hence we have 5 times 10 to the negative third kilograms of water. Now that we have those two pieces of information, can you answer this question? So go ahead and try to figure out how to use those to answer the question of, will this freeze at negative 18 degrees Celsius? I'll give you about 2 more minutes.
He's like the wrong, but nice try.
What is the key of value for this one?
What'd you say?
Key of value for this one?
Well, I mean,
It is Google.
Alright, we need a little bit more time. Raise your hand if you want another 30 seconds or minutes.
8.503.
There's no one raising their hand, so we're done? Good? 30 more seconds, make sure your work is worked out. Alright. Has everyone submitted their answer? So let's ask it this way. We have an overwhelming set of responses for one of the answers. If we have the molality, which we just found the number of moles of solute, the kilograms of solvent, what do we use for KF? KF?
1.6.
Degrees Celsius per mole.
Yep.
What's our Van Hoff factor? Why are we assuming 1? Because it's molecular. There are no ionic bonds, and hence Van Hoff factor is 1. So then what do we find for delta TF?
0.39.
Degrees Celsius. Which means that if we put that in anything that was colder than 0.394 degrees Celsius, it would freeze. And that is when the majority of the loss time.
Did you give us the fixes like?
No, there's just a no-tell fix. Okay? So these are the types of questions that we can answer and think about what would our concentration have to be, would be another way you could ask this question, right? How much solute would you actually need to dissolve in order to get that to not freeze at negative 18 degrees Celsius? That would be an even more complicated version of this question. So then we'd say negative 18 is our 18 is our delta TF. We know our I, we know our KF, we know our molality, or we would have to find our molality that would allow that to happen. It's going to have to be a lot more concentrated, right? So there's a number of different steps. So that's one of the last things that we're going to talk about. How much time do we have? Not enough time? So, big picture, so far we've talked about you add solute and you change the solution. The first three things that we changed, we haven't really talked about vapor pressure. That's Raoult's law. I think that was in one of your homework questions. So once again, if we talk about changing of colligative properties by the percentage of the surface that's changed, that's what Raoult's law does. It says what's the mole fraction, or what's the percent of all the molecules that's blocking the surface, and that's what's going to change the vapor pressure. Osmotic pressure is the only one where you assume that the temperature doesn't really change, and because of that, it sounds weird, but we use molarity instead of molality. So all the calculations we're going to do for colligative properties involve molality or mole fraction, but the one different one is osmotic pressure. So, you all good at calculating osmotic pressure? Do we know how to do this? Just looking at the clock and thinking about where we want to spend our time. Pi equals IMRT. So what is pi in this equation? That's our osmotic pressure. I is our Van Hoff factor. What is M in this case? Molarity is the big M. You have to be really careful not to use molality here. And then what is R? It's our gas constant. One of the things you're going to find potentially in your homework is that if you use a different pressure, if you're given the pressure in torr or in millibar, you have to be really careful because your gas constant has units that you have to have the same. So if you're doing calculations in torr, you want to convert everything to atmosphere if you're using this constant. Or you can look up another version of this constant that uses torr. Just using a conversion factor to get there. And then T, what's the biggest pitfall with temperature? We want to use Celsius all the time, but it doesn't work here. So this has to be in Kelvin. So I'm going to actually ask you a question here. If you go into a medical career, they're going to talk about osmolarity of solutions. So one of the questions I have is, how do you define osmolarity? So if you look at a couple different solutions here, if you have pure water, it's 0 osmoles per liter. If you have a 2 molar solution of sucrose, we say that's a 2 osmolarity solution. If you have a 2 molar solution of sodium chloride, it's a 4 osmolarity solution. What does osmolarity mean? What's the relationship between molarity and osmolarity?
Water wants to have the same concentration of solutes in it. So it's going to like try to move.
Okay, so you're getting a little bit past where we are. You're talking about osmosis. I'm talking about this type of concentration that's just called osmolarity. And it sounds similar to molarity, but it's a little bit different. So what is a 2 osmolar solution of sucrose is a 2 molar solution. But a 2 molar solution of sodium chloride is a 4 osmolar solution. So on your piece of paper, write down what you think osmolarity is and how that relates to molarity. So how does it relate? Can I have a volunteer? Any volunteer? Someone's been quiet. How does osmolarity relate to molarity? Michael? Yeah. So in your body, you care about how many particles are in solution. So if you have your blood is hyper or hypotonic, you're going to have a lot of problems with red blood cells bursting and your body going into a lot of trouble. So we don't really care about molarity of solution in our body, we care about the osmolarity. So as Michael said, it's the molarity times the Van Hoff factor. Tells us how many particles of solute are there. There's a cool little YouTube video that I'll send out that you can watch. But in the last, I don't know where I'm going. I'm going this way. In the last couple of minutes of class, I want us thinking about Alright, so there's this weird thing called a U-tube. It's a glass tube, but instead of being a straight glass tube, it has a bend to it and it's U-shaped. And right in the middle, you can put a membrane, something that allows water to flow through in both directions, but nothing else to flow through. Only water can pass through it. On the two sides, you're going to pour in two different concentrations of sodium chloride. The one on the left is saline, that's what you use in an IV bag. The one on the right is about half that concentration. If we leave it for a short period of time, what's going to happen to the level of water on the two sides? Is it going to go up on one side, is it going to go up on the other side, or are they going to stay the same? So go ahead and think about your answer and click it in. Try to convince the people at your table that you're right. Right now we're split 50-50. Well, 40-20-40. All right. Let's go ahead and close this out. Submit your answer. So we're still pretty much split right down the middle. So if we were to go on the Magic School Bus and look at that membrane right there, are we going to see a higher concentration of particles on the left side or the right side of the membrane? Left side. And so what water does, Jesse kind of alluded to it earlier, is that water will move in the direction that will try to equal out the concentration on both sides. So is water going to move from the left to the right or from the right to the left? So the water will move from the lower concentration to the higher concentration. The water is doing the moving, right? Water can pass back and forth as much as it wants. And in doing that, it's going to keep moving until the concentrations are equal, or there's something pushing back on it that doesn't allow it to go any further. In this case, the U-tube has gravity, so this isn't going to be able to get to exactly equal concentration on both sides, because gravity is pulling down on this one more than it is on the left side than the right side. If you're in a cell, the term hyper and hypotonic, hyper means greater than. So in the original case, the left side was hypertonic, the right one was hypo or less than. You can only use those words in relation to another one. You can only say, I'm shorter than someone, or taller than them. It's the same thing with hyper and hypotonic. Hyper means greater than something else. So we didn't get a chance to talk about how to use osmotic pressure to find molar mass. Let's spend the first half of class on Monday doing that. What should I do about the homework? Because it has a set of questions on that. Do I delete that set of questions and put it on something else? Do I make the homework due Monday night so you at least try it? I would prefer to do that. I don't want you to wait. And we do have an exam Wednesday, so I'd like you to try everything. Can I keep them on there, make it due Monday night, but do not wait until Monday night to do the homework, because it's going to be absolutely miserable. Is that fair?
Sounds good.
And there's a post-quiz. Post-quiz will be due probably Tuesday.